Hello, good evening all. Welcome to this first session for NPTEL Live Geotechnical Engineering 2. I'm Fakira Rashid. I'm your TA for this course, and I'm a second year research scholar working with Professor Singh. This is our research lab, and we are going to start with a round of introduction for every research scholar that is here. And after that, we'll be going towards the questions that have been asked in the course of this 1 week or so. And after that, we'll be taking the questions that come in the live session. I'll start with the PS here. He'll be introducing himself.
Yeah, hello, good evening all. I am Singh. I'm a second year. I have completed my second year of PhD under supervision of Professor Singh. And I am working on the topic of utilization of waste rubber tires, mainly focusing on replacing sands and gravels. So, at many places for infrastructure development, we use generally coarse grain material and fine grain materials. And now, there's a scarcity of natural aggregates. So there is an urgent need to utilize the waste materials or industrial byproducts. Then here comes we have a lot huge amount of rubber tires, which are lying here and there, and ultimately they affect the geo environment if they left unattended in the terms of fires and those things. Now I am trying to make sand-like particles or aggregate-like particles from waste rubber, and ultimately I want to replace sands and gravels. So in case of sands, like we talk about rigid porous media, our matrix is totally rigid in system, and the deformation will be due to crushing of particles or due to rearrangement of particles. But in the case of rubber particles, these particles itself are deformable in nature. So here, we will be seeing that the matrix is deforming due to the rearrangement of particles. Then there can be deformation of the particle itself. So this is totally different geomechanics itself. That basically I am trying to understand. I am focusing on different applications. One other application is in the case of composites. We can replace fine like sands and or gravels in the concrete using this material. There comes how this material will behave with the cement. What is the interaction? How is the interface? So these are basically research topics and on which I am working on. And those who are interested and want to learn more about these topics, so they can visit the professor website that you can easily type on Google DNS ITB, or you can just search and you can get details of mine and my Gmail ID. So you can send your doubts on my Gmail ID, and in case you want to learn further, feel free to contact me. So thank you very much. Thank you for that.
Thank you, PS. The next research scholar is Mrinal. He'll be introducing himself.
Good evening, all. I am Ronald. I am working under supervision of Professor Singh, and my topic is valorization of dredge sediments. Basically, dredge sediments are we get from desiltation of dams, or if we are doing dredging activities in river for enhancing the discharge and uh, for reducing the flood waters, and also in offshore environment, offshore we do dredging. So for what is the way forward where we can use this material? So these are all anthropogenic materials. So as PS said, Vijendra said, there is scarcity of sands and gravels. So I'm trying to utilize this material with by valorizing it for the infrastructure development, agricultural activities, and so on. So my topic basically I am working on the theme of bulk utilization of dredge sediments.
Thank you very much, Mrinal. Now, Goli will be introducing himself.
Thank you, Bhutta. Good evening, everyone. Myself, Goli. I have completed 4 years of my PhD work under the supervision of Professor Singh, working on the topic of landfill mining and how to utilize different fractions or materials comes from landfill mining activity. So you must have seen or heard about the nuisance that is being created by the landfills or dump sites. Now, one of the ways to avoid these kind of issues is to mine this material as well as mine these landfills or dump sites and utilize them for some sustainable development applications. So with this motto, I have started my research work. Then in the process, we have realized that many of the existing characterization tools are not sufficient enough to establish or characterize these landfill mine residues. So we have developed several methodologies related to characterization of these materials, like how to utilize for different applications. For example, agricultural soil enrichment applications, as well as in terms of establishing microplastics concentrations in landfill mine materials. Apart from this, I'm also working on how to utilize plastic fraction that comes from landfills in terms of recycled polymer composites. So one of the ways to get rid of the plastics instead of going for thermal treatment is to go for mechanical recycling. Therefore, you will be able to enhance the life cycle of the plastics in their original form. Also, you'll be able to replace some of the conventional materials such as decorative items and then structural components like pavers, etc. So, but the issue is when we have mixed kind of plastics coming from different sources, how they will be able to compatible with each other, whether they will be able to provide mechanical properties or the durability of the end products which are up to the mark or not. If not up to the mark, how to enhance their durability and mechanical properties. These are the few aspects which I am focusing on right now. You can go through Professor Singh's website to understand research recent outcomes. Also, you can go through the profile of Professor Singh, research gate profile of Professor Singh and all our profile. If you have any more queries with regard to specific to my research activities or any of our research activities, you can contact us through email, which is available on Professor Singh's website. And I look forward to have a fruitful interaction today. Thank you very much. Thank you, Pakra.
Thank you very much, Gudi. Now, Singh will be introducing himself.
Hello, good evening, everyone. My name is Singh Manohar. I am working under the under the Professor DN Singh, and my topic is risk associated with carbon sequestration. And mainly, I will deal with what are the risks associated with when I inject the CO2 in the reservoir. And as you know, different type of reservoir, the aquifer. Then I will mostly I will understand the behavior. How does the reservoir will behave after injecting CO2?
Thank you very much, Singh. Now, Arisa will be introducing himself.
Hello, good evening, everyone. I am Srinivas. I am also a PhD student working under the supervision of Professor DN Singh. And my research topic is gas hydrate bearing sediments and its mechanical properties. And these gas hydrate bearing sediments, as you are already aware that these are the deposits in which the methane gas is actually entrapped in the water molecules, and you will find their habitat in along the marine offshore basins, some of the offshore basins in India and in permafrost regions. Some. And you actually this we are looking at this problem from the geomechanics point of view. You might have studied different phase relationships in the first course, Geotechnical Engineering 1. Generally, when you have a fully saturated soil, you will have two phases, or if it is partially saturated soil, you will have three phases. But in case of these hydrate bearing sediments, we have more like gaseous phase and hydrate phase will come. So it is one type of best example for the multi-phase soils where you will find different number of solid phases and a gaseous phase and liquid phase. So when these hydrates are actually sitting in the soil or sediments, marine sediments, it will have it will gain improvement in the strength. But when you are extracting this gas from the sediments, it will lose its strength. So for to understand its behavior in terms of geomechanical property variation during the gas extraction, we are trying to do some laboratory experiments as well as some numerical simulations, and we have different experimental setups with the Professor D.N. Singh's lab, that is Environmental Geotechnology Lab of ITB. And if you have further queries regarding this research area or any other, you can find the details of all these research scholars in the professor's website. You can contact us. And there are some very good papers published by professor on this topic, some review papers and one or two work papers. You can go through if you are really interested. You can send the emails to us. And welcome, finally welcome to this course and this live interaction session of this course. And I think you are enjoying the course content. Thank you very much.
Thank you, Anisar. Now Yogendran will be giving his introduction.
Good evening, all. I am Yogendran Narayanan. I am a first year research scholar under the supervision of Professor D.N. Singh. My work area is geological storage of carbon dioxide. As RSR has previously mentioned, it also comes under the realm of multi-phase geomechanics. Basically my intention is to study when a reservoir that is saturated with brine, that is salt water with high salinity, when we are injecting carbon dioxide into that formation, how it will interact with the pore fluid, that is brine, and how it will alter the geomechanical properties of that reservoir. That is my main intention of study. Regarding geomechanical properties, it will include shear strength, deformation, modulus, the compressibility, etc. This will be studied by non-invasive techniques. And welcome all to the course. If you have any queries regarding this area, you can visit my profile in Professor D.N. Singh's website, and you can contact me through email. Thank you.
Thank you very much, Yogendran. So by now you must have realized that the theme of our lab is divided into two groups, that we are working into the waste management and the other part of the group is working with the energy geotechniques. So my topic, and I'm mostly working in the energy geotechnics part, where I'm trying to find the feasibility analysis, how much heat can be extracted from the oil wells which have been decommissioned. Like as you must be knowing that geothermal energy is conventionally being taken out in the areas which are in the volcanically active areas. There are very few countries around the world which come in a specific ring of fire, which are very much close to the volcanically active areas that are plate boundaries. Their heat extraction can be done very easily. We don't have to drill that much into the earth, and we can get the high temperature. But there are some scientists which believe that because it is very much concentrated at certain places, we can go look for the areas which are sedimentary basins. Through that, we can extract the heat, which are very much available throughout the world. But there the thing is that it's a low enthalpy region. That is, the heat that can be extracted is very less from this region in the shallow depth. So we have to drill more in these areas. So another concept is that we are having oil wells, which when they lose their life in the sense that they cannot be used for the furthermore oil extraction, we can use them for the heat extraction because they are drilled already for 3 to 4 kilometers and they will be having a high temperature in the range of 100 to 150 degrees Celsius. So there this topic comes that can the heat energy from these areas which are not in the high enthalpy region, how much heat can be extracted from this? So when we talk about the heat extraction, we have to see about it certain regards like which fluid to be used for extracting this heat, how this reservoir, which is having properties in the form of thermal properties and the reservoir properties in the sense of porosity and permeability, how it will be reacting, which is at high temperature when a low temperature fluid will be moving through it. Also, this fluid we are using can be of certain types in the form that it can be water, or we can use CO2 as a fluid so as to add on to it and we can sequestrate it also. So this is where my topic is, where I want to study if a fluid is being injected into the reservoir, which is at high temperature, how much heat we can extract and how our reservoir is going to behave, so as to get an idea for how much duration we can extract this heat. That's all about the topics, and we'll be taking the questions now. Initially, we have a question from Mr. Abhishek, and he's asking that what are the field methods to increase the shear strength of the soil? So I believe it's the methods of ground improvement there is being asked, like what are the methods we can do in the ground to increase the shear strength? So I'll start with it, and everyone will be giving their own answers. Just to start with it, it will depend on mainly on the type of the soil or type of the field you are having. If you are having a very clay soil at your site, we suggest that you go for a, initially to start with, you can go for a replacement method where you can use sand or silt, which is not having that much plasticity, to decrease the plasticity of the clay that is at the site. That can be the easiest part of the initial shear strength development. The another way is that you can compact the soil. So there are different methods that can be done. Like you can have a static load at the top of the soil of yours or the site of yours, so that it can get compacted and it will enhance the strength of the soil. There are other methods too where you can use a vibro compactor, or you are having a load and that is getting compacted so that your site gets enhanced in the shear strength. Apart from that, there are other methods too, which other of my research scholars they will be giving much more examples.
Yeah, I think like that's a very good question, and Agra has covered most of the points. So here, like when we talk about the shear strength of the material, so it depends upon like material to material. Like in the case of sands, we will be seeing that angle of internal friction dominates, which controls the shear parameters. While in the case of cohesive soils, the cohesion like takes the major part. So now when we are talking about like how we can enhance some property, so we have to basically optimize the C or phi parameter, which will be controlling the C extent of the material. And there are different techniques which like possibly covering in this course, or you can read from books. Like there are different ground improvement techniques where we can use physical methods or chemical methods, or even biological methods are also being used to improve the the property of the ground, basically strength parameters. So I think like this is a very good area, and in this field, like a lot of scope for research is also there. So I think most of the points have been covered. Thank you very much. Anyone can.
Yeah, like colleagues have given few of the examples how to improve shear strength of the soil through ground improvement techniques. I'd like to share a few more examples. For example, this is in particularly when you're dealing with clay type of soils in marine deposits, which are not properly kind of consolidated. Most of the time, these marine deposits are kind of sediment deposits and which are loosely compacted or consolidated. So they will not be having enough strength to develop infrastructure over it. So more often, like that the is what they do is they'll try to and consolidate this material through dissipation of pore water that is available within the clay materials. So for which there will be application of surcharge load as well as dissipation of pore water pressure through PVD installation, prefabricated vertical drains, etc. So it might so happen that few of the situations you will not be having, I mean, the soil may not be having enough strength to even carry the surcharge load, etc. In that case, there are techniques like stepwise consolidation, etc., which will help us in consolidating the material layer-wise, so that we will be having enough strength to go further. So this is one of the ways to consolidate and improve the ground. You can see this kind of techniques mostly in marine environment or coastal environments. Thank you very much.
We have a question in chat box that Puran Bande, she's saying that she's from third year civil engineering student in CU, and her question is, in one of the textbooks, I couldn't understand the effect of the long-term and the short-term effect of rise and fall in the water table on the effective stress at a given layer. Can you please clarify? So to start with, I will like to make you understand that effect of if it is pore pressure. Yes, the water table as it goes up and down will be having an effect in the form of pore pressure. As you'll be knowing that the total stress that is at a place, sorry, the effective stress at a place will be equal to the total stress minus the pore pressure that is getting developed. When we talk about the short-term effect, we see that the water table will rise and the strength at the soil side that will become a saturated soil. But immediately there will not be any pore pressure that will be getting developed. So in the form of effective stress, there will not be an effect. But when we talk about the long-term effect, then the pore pressure get dissipated and it will get subtracted from the total stress and the effective stress will decrease when we talk about the long-term effect. So maybe that gives you an answer. Would someone like to?
Yeah, so here, like, from what I have mentioned, like here, like the type of soil also plays a major role. In case like you are having sandy soil, now your water table is decreasing. So like with the decreasing, like here, like in whatever question is that the these type of problems are there. Ki at instantaneous what will happen and in the long term what will happen. So if you like part of the fine grained soil, so with like lowering of water table, the water from the pores will not be dissipated out at the instant. So instantaneously your system will not change. So at equal to 1 second or like an instantaneous effect, there will no effect in the effective pore water pressure, effective CST values. But in the long run, like that soil, the changes will be there. So you have to like look into the type of material first thing, and then the condition, like whether water table is decreasing or increasing. So you have to consider both this, like both of these situations to calculate the CST parameters.
I hope this answers your question, Brian. Apart from this, are there any more questions? Okay, thank you very much for your time. And I think we are not having any more questions, so we'll be closing down this session. Uh, Apart from this, if you all are having any more questions regarding our research or any other questions regarding the course, whatever has been covered, if you want, you are having some doubts, you can anyhow reach to us through Professor's website. Every one of our Gmail accounts and email IDs, they are there, and you can go through what we are into as a research group, what is the topic that we are covering, and every one of our work is there, and the papers that has been published by this group that are there too. You can go through them, and whenever you want a discussion, you can write to us, and we'll be responding very soon. Thank you very much.
Thank you all.
Thank you all.